Okay, so this is problem 13 off of the chapter 18 homework. Um, the problem asked us what the height was, so we were trying to find the height of a swimming pool that is 4 meters wide and is completely full of water and has the sun at a 20-degree angle above horizontal. So it's 20 degrees above horizontal, and it's going in, and the light is not hitting, it's not touching the bottom of the pool. So no light is hitting the bottom of the pool. And so using that information, it wanted us to find out what the height was. So to do this, we had to figure out what the angle is with the refraction, and we are using this top angle because that's where it's going to refract. And so we have this angle, which is 70 degrees, and we're going to use this equation. And so we have the index of refraction times sine of our first one, which is 70 degrees, and our index of refraction of this top part is air, right? So that's going to be 1. And then equals the index of refraction of this, which is water, is 1.33, times the sine of this, right? And so we'd have to figure out what this angle is, right? And we can use this equation and we can plug it in. We can just turn this right here because we know that it's not going to touch the bottom of the triangle right here. So we can make this just a triangle, and we can use the Pythagorean theorem, right? And so, this would just be, SOHCAHTOA, so it's going to be opposite over hypotenuse, right? And so we can find out what this is, right? And we have this right here is 4, right? And so so when we plug that all in, it ends up being 16 plus ry, which I just called this side right here y. And we can just plug that into our equation, right? And so we can replace that with this, and you can just work that all in there. And so we end up getting n1, which is our index of refraction, times sine, which is this still, all over this, which is our equation for finding out what y is right here, which is our height. And so we have our height right here, right? And so we just have to rearrange this. It's kind of ugly, and it took a minute. And so once we can swap these right here, and then we subtract, or then we square it to get rid of the square, and so then we square that, and then we minus the 16, and then this was squared. Yeah, so this was squared actually. Silly me. Okay, and so then we subtract the 16, and then we square rooted it, and then we got y equals this. And then once you run all of that, you end up getting that it's 4 meters tall. So it's just kind of a box. So this is kind of inaccurate because I drew it as a rectangle, but it's 4 feet tall and 4 feet wide. And that's how we do it. And so the key components were using this equation and then being able to find it. So